Everyone. Thank you very much, Terry, for the introduction. I'm an independent consultant to aerial applicators, large farmers, and chemical companies on how to make chemicals work better. So I work with aerial applicators around the world, with the main concentration being in South America. And I work with low volumes to increase efficiency and reduce environmental impacts. So my subject that I've been asked to talk about is how to properly adjust aerial application equipment to match droplet size to pesticide selection and field conditions, using low volumes to reduce environmental impacts and increase efficiency. First thing I'd like to highlight is, in my view, it's time for us to take a new approach. We need to pay some attention to what Einstein said. Stop repeating ideas that do not work. The definition of insanity that Einstein gave one time was someone who's repeating the same action process over and over again, expecting different results. Very clear example in the pesticide business is how we're applying chemicals. Rust control and application of acaricides especially. These need smaller droplets and lower volumes, not high volumes. Increase in spray volume to match increase in leaf foliar index. False. We need to reduce the droplet size and reduce the volume. For better coverage, increase spray volume. False. We need to reduce droplet size again and volume. When the temperature is higher, increase the volume of water to offset evaporation. This is absolutely false. The water always evaporates. We need to reduce the amount of water and add a non-volatile carrier, commonly oil. Change the position of the boom on the aircraft to reduce drift from vortices. I believe I was the first person ever to do this as far back as 1973 on this Z-37 aircraft in Hungary. The boom was following the trailing edge right out to the point of the wing, and it caused a lot of drift. In fact, drift with a desiccant went 50 miles. Within a few hours, I repositioned the boom in this fashion. You can see it's much shorter. I dropped the boom. There are no nozzles on the fuselage, and we resolved the drift issue. The main issues with drift for me started right at the very beginning. Huff Dallin dusting 1924 applied pesticides as a dust. Obviously, it was difficult to handle, difficult to load the aircraft with one man in the back throwing it out from a drum. So some bright person had the idea we should mix it with water. That was the first step in the wrong direction from my perspective, because water evaporates. Early on in my career, I was involved in testing chemicals. I worked for a chemical company. And one particular chemical would not work in England. In 90% of the tests, it did not work. A decision was made to stop development of the product and to burn all active ingredient, end of project. But I've kept the product, I played with it, I discovered that the chemical needed heat. So I took it to Spain, I applied it on olive trees in a very hot region of Spain, temperature often up to 110 degrees. And we applied this chemical at 110 degrees using this Pawnee on the left photograph with a spray volume equivalent to 1 quart per acre. We had 100% control of the pests. The same year, I did further work in Yugoslavia, mosquito control, applying 200 milliliters per hectare. It's about 3 fluid ounces an acre. I put an extension to the exhaust pipe, injected the chemical in. These two things really turned my mind upside down, because I'd been working with crop desiccants using high volumes, and then I discovered that low volumes also worked. Here's an instance. I was called in to help in Bolivia. The locust attack just 2 years ago. We controlled it using around a quart to the acre. No water. Spruce budworm. Many of you know that spruce budworm is a major issue. And how is it controlled? Applying Bacillus thuringiensis at a very low volume, 2.5 liters a hectare, again slightly over a quart to the acre, very successfully. The same active ingredient is also registered for other uses, where it's recommended to spray as much as 100 liters or 10 gallons an acre. So here we have a contrast. To spray the trees, the aircraft must fly high. The trees are 15 meters, let's say 60 feet height, 50, 60 feet high. And the only way that that product can get down into the canopy is to use low volumes, not water. The water evaporates. Let's look at what happens when product is more concentrated. Here's a graph of work done in the early 2000s, around 20 years ago, with glyphosate. It was applied at various spray volumes. You notice the top line, the graph was prepared in metric, so it's 23 liters, that's about 2.3 gallons an acre. It gave 85% control of this weed. When it was applied in 19 gallons an acre, the bottom dotted line, it only controlled 45%. Let's look at the middle numbers in the graph. When we look at where the arrows are in the middle, for high volume to have the same control as low volume, it is necessary to use 3 times more glyphosate. The first time I saw glyphosate, I found it with a dealer down in Brazil, where I spent a lot of time. It said on the label to spray 40 gallons to the acre. I have a special sprayer that I use for development work. I sprayed it at 1 quart to the acre. I sprayed it at 6 o'clock in the morning, and the grass was desiccated by 6 o'clock the same evening. The product works much better at low volumes. And I can assure you, all of you who are listening, pilots, over 90% of all glyphosate applied in South America, especially Argentina, is applied using less than 1 gallon per acre. We have less drift because the product is more concentrated. Pure glyphosate does not evaporate. If we spill it on a loading platform, it will take 2 to 3 hours to dry, and even then it's not completely dry. So it's non-volatile, it's systemic, it does not need small droplets. The best way to reduce drift is to reduce the amount of water. Drop size, how big is 100 microns? I listened to earlier presentations about micron size. That's my left arm on the photograph. A human hair is roughly 100 micron diameter. If you look carefully, you'll see a number of droplets caught in the hairs. If we apply products with 2 smaller droplets, they will not deposit. They will behave like smoke. If we apply the products, such as glyphosate, with 100 micron droplets, or in this instance, the droplets are probably 120, 150 microns that are visible on the hairs, the droplet will stay on the hair and will not hit the leaf. This was proven to be the cause of failure to control a major disease in Brazil, soybean rust. It's necessary to add an oil adjuvant so as the droplets will spread after they hit the target. I stood underneath an aircraft for this photograph. I don't recommend it, but I had a very specific purpose in mind. I wanted to show my client the drop size, and human hairs are fantastic to collect small droplets. Also the face on my watch to observe the life of the drop. A droplet must stay wet. The photograph on the right shows the dispersion on the bumper of the director's car on this farm. There is quite a lot of dispersion of the droplet, but not enough. So it's necessary to add further adjuvants. Pyrethroids. Contact action requires contact with the target pest. If we apply a product of 3 to 5 gallons an acre, any of the pyrethroids, we have to wait 24 to 48 hours to have control. There's poor penetration because the drop size is relatively large. There's severe limitations with temperature and humidity because of evaporation. If we go in low volumes, we get control in 15 to 60 minutes, 95, 98% efficacy. We have better penetration, and we have no limits on temperature since there's no evaporation loss. Here's where the environmental question comes in. If we apply in high volume, where did the chemical go? It obviously did not hit the insect, so it must have ended up in the soil or the air. Contact action requires contact with the pest. Here's a fungicide. I did a lot of work for this company. The label was 5 gallons, and then they hired me to check what would happen if the label was changed to 2 gallons. So I conducted tests all the way from Louisiana right up to the border with Canada, and was able to prove absolutely that 2 gallons gave better disease control than 5 gallons. I subsequently did more work and was able to prove that 1 gallon was better than 2. Very simple reasons. When they lower the spray volume, the product is more concentrated. When they lower the spray volume, we have less water, so there's going to be less evaporation, so we're going to have more product that hits the target. Power of redistribution of droplets with a good adjuvant. This was an application on bananas in Ecuador. 2 minutes after application, I took this photograph on the bed of the pickup truck, and my heart did a jump. Wow, how horrible distribution. As you can see, it looks terrible. I came out from the banana plantation later, and before getting in the truck, I had a look on the platform of the truck in the back, took another photograph. It was 18 minutes later with almost 100% coverage, and the droplets were still wet. This may be a new observation for most of you, but for me, it's fundamental. If the droplet does not stay wet, the application was a disaster. Rice, easy coverage, high volume. If we apply high volume in a crop of rice, or it could be wheat, just imagine for a second, you're a large droplet and you're coming out of an aircraft. Where are you going to land? That's the view of a droplet coming down. 90% or more of the drops are going to hit the ground, not the crop. Pollution, direct soil pollution, contamination. If we use lower volumes, a smaller droplet, the droplets go tangentially, sideways, and more of the chemical will hit the crop. There's the same field. Sulfafenicil, the contact herbicide. The labels, with due respect to the lady that just spoke, labels are very often wrong from a technical standpoint. The label for this chemical initially recommended high volumes, 20 gallons an acre and 5 gallons minimum by air. I conducted massive tests throughout South America and was able to prove with dramatic results, when we lower the spray volume, the chemical worked much better. And at this point, we need to ask ourselves, why does the chemical work better? Obviously, because more was on the target. The best results with ground application were around 2 gallons an acre with a ground sprayer. And by air, the best results at 1 to 1.5 gallons, not more than 1.5, please. You get more drift with higher volumes because it's the water that evaporates, it's not the chemical. Drift control and buffer safety margins. Can we apply with an aircraft without causing drift? Yes. Here's 2 examples from a good friend of mine in Brazil applying ripener to sugarcane. You can see the area that was treated and the buffer margin, there's clearly 50, 60 feet there, untreated, very dramatic, precise application. What happens with drift environmental? Here's a GPS map. The pilot had been using the electric brake on the pump and not the bypass valve. We can see what happens. He's spraying back to back. when he's coming to the end of the spray run, he flicks the switch to stop the pump stops, but the system is pressurized, and if the aircraft is flying at 120, 140 miles an hour, he's a considerable distance past the end of the field before the equipment stops spraying. So here's a basic issue, and the same problem when he's re-entering the field. He switches, releases the brake. It takes a second for the pressure to build up, and the second with a turbine aircraft, he's doing 160, 180 feet. So there's going to be a gap. Effective swath. Excessive swath width where a desiccant was applied. This aircraft had actually been calibrated using the string deposition system, which determined the specific swath for the aircraft, and you can see it's all streaked. The photograph in the middle and the right, that is glyphosate as part of a test, applying glyphosate at different flying heights to see the true swath. We must conduct the flight pattern test with the chemical, not with water. Please, we have had multiple failures because of this. The swath width with the chemical is very different in a crop than it is on a piece of bare ground. The most dramatic being tall crops such as sugarcane, 10, 12 feet tall. If we do a pattern test on a piece of bare ground, the swath width will be at least 10 feet wider than what it will be in the crop. What's the correct flying height? Many people say, oh, a turbine aircraft, you must fly low, 10, 12 feet, equipment above the crop. But what happens many areas, even Minnesota, Canada, there are a lot of trees, smaller areas in the middle of the trees. A turbine aircraft cannot come down to normal operating height, so the plane has to be spraying at 50 feet altitude. This was a major problem for one of my clients. He had a lot of areas like this, applying fungicides, and the chemical did not hit the target. First goal was increase spray volume, 3, 4, 5, 6, 8 gallons an acre. The chemical did not arrive due to evaporation. I made a number of tests, and I was able to prove very dramatically that the solution was to reduce spray volume, take out the water because it's the water that's evaporating, drop back down to half a gallon maximum, and the chemical not only reached the target, it worked perfectly. Here's a major disease in Brazil where I've been doing a lot of work. The field on the left was untreated. There's nothing there for the combine to harvest. And where it was applied on the right, that's 0.6 of a gallon roughly to the acre. Fantastic control. I work with many aerial applicators around, especially around Brazil. Practically 100% of the fungicides being applied in soybeans are applied at less than 1 gallon an acre. We're working under very tough conditions, high temperatures. We never stop an aircraft for temperature, never stop an aircraft if the humidity is low. We adjust the chemical mixture. The reason being, we want the product on the target. It's not sufficient to have it on a piece of string. It must cover the crop. Here's some data that clarifies what happens with water in high volumes. This is deposition work for a chemical company, 3 gallon an acre. Note the deposition, 35, figure 35 on the left was the analysis with 3 gallons an acre. Very irregular, 3 passes of the aircraft with wind from the left. When we applied 1 quart to the acre, the deposition jumped to 60. Just look at that again. 35 and it jumped to 60 when we applied low volumes. The product reached the crop. It did not stay in the air. What does this mean? This means this with drift. When we apply low volumes, you can see the solid line is low volume at 1 quart to the acre. That's number of feet downwind on the bottom. At 165 feet away from the line of flight, we had 90 measurements of chemical in the air. With high volume, there's only 40 bigger droplets. Yes, definitely. 3 gallons an acre, bigger droplets. But look what happens at 200 feet, 660 feet, 600 feet. The lines crossed over. This is air sampling. At a half mile, there's about 6-8 times more chemical in the air, more drift at a half mile with high volume than low volume. Evaporation. What volume is necessary for good coverage? I'm just over 6 foot tall. I'm not on my knees. That's the type of soybeans crops we have in Brazil. And actually their average yields, the yields in Brazil have now they've exceeded the yields here in the United States. So it's high productive soybeans. And the spray volume required is 0.3 of a gallon to 1 gallon. Weather conditions. Everyone's concerned about wind. Many people even still say, don't spray when it's windy, spray earlier in the morning. I've proven with my clients that it's the opposite. We must not spray if the wind is less than 2 or 3 miles an hour. That's a minimum. If we've got air stability, observe the hawks or eagles. If they pick up on a thermal and go straight up, we need to stop flying. Flying height. Remember, if the aircraft is flying very high and we're using water, we're going to lose it. Just think back, spraying a budworm in Canada, a mosquito control, a locust control. Aircrafts typically flying at 50 feet, 100 feet, even 150 feet for locust control. But we're not using water. All the chemical comes down. When it doesn't come down, we have evaporation loss, we have drift. Temperature and humidity. There's a lot of data about what happens with drop size, but all this data is irrelevant if the drops are evaporating. But when we mix the product with non-volatile carriers, the product is no longer sensitive to temperature nor relative humidity. The combination of both add to drift. Beautiful weather station, tons of data, but what does it mean? I'm working a lot with additives for chemicals. We need to minimize the effects of high temperature and low humidity. And when we have the mixtures correct, I repeat, we can forget temperature, humidity. Effects on drop size. Here are 2 major aspects that make me nervous about environmental control. If we go high volume at maximum deflection, for this example, to show the extreme, for small droplets of 4 gallon, look at the drop size on the bottom scale, up to 1,000 microns. There's 48% of that chemical in the target range, 100 to 350, which is ideal for a fungicide. If we drop the spray volume, we get 73% of the volume in the target range without increasing our drift. We can see on the left, the very small droplets, 0.5%, even take 150 micron droplets, we're around 5% total. It's still only about 5.1, maybe 6 with the lower volume, but we have more product on the target. And remember, if it's not on the target, where did it go? Here's a more detailed one. 28% of the volume in droplets larger than 350 microns, and less than 2% under 150. Fluorescent products. Here's a good example of an aircraft applying 5 gallons an acre down in Mississippi. Beautiful. The aircraft's at the right height. The vortice doesn't exceed the wingtip height. Perfect. But look at the pollution on the ground. This is contamination. If we use a smaller drop size, the droplets go tangentially. They go on the crop with less on the ground. SWOT analysis. This is one of the first systems with Professor Larry Roth, who is a dear friend of mine, I know he passed away a few years ago. We worked together in South America. The system is beautiful, but does not bear any resemblance to the penetration or coverage or swath width within the crop. And to put cards on this aluminum strip, they do not collect the smaller droplets, because the airflow will carry the droplets over the strip and they will not be deposited. Here's what we've developed in South America. We use mirrors and water-sensitive cards. We must use lower volumes when the conditions are hotter. This photograph on the left is in Bolivia. We're spraying soybeans very commonly, I would say every day, between 95 and 105 degrees. The droplets must stay wet. As a friend of mine at the chemical company said, plants do not drink rocks. That's Gregory, he put it in those words. The chemical will only be absorbed in the crop within the leaf if the droplet is wet. Just think about it for a few seconds. A very large number of the pesticides, I say pesticides because we're talking about all types of products, are formulated in suspension concentrate form or powder or granules. If we mix them up in water and we spray them, these droplets are dry on the leaf in a maximum of 30 seconds. My goal is 5 minutes minimum. All the products, I can assure you, every single product that we apply in agriculture works better when the droplets stay wet and they hit the target. They do not evaporate. I've seen the back of my car after driving in the snowstorm. Where does the chemical go? The smaller droplets, the smaller particles stick to the back of the car. All the windows were clean. Even on the back window, you just see a little bit of snow around the edge. Spraying and deposition analysis. From my perspective, a scientific perspective, all droplets deposited on flat collectors at the base of a crop or on a flat collector on an airstrip is a measure of lost product, with very few exceptions, such as pre-emergent herbicides, white mold, soybean inoculant. This is something that may shock some of you. I have very many clients. Last year sprayed around 2 million acres applying inoculant to soybeans from an aircraft on the ground and on the young soybean plants. In this instances, we want the chemical on the ground. Leaf spot disease. I just show you this to highlight, where does the chemical go? Fungicides with aerial application, you notice the degree of control. Leaf spot severity on the scale on the left. With high volume ground application, we lost control of the disease. I would ask a question, why do we not get control of ground application using lots of water, if water means better coverage? The water gets there, but it's going on the ground or it's evaporating. Aerial application, the spray volume used by this company is 0.5 gallon. It's the largest grower of peanut in the world in South America. They use 2 turbine aircraft. Another very dramatic example, environmental pollution. Around the world, there's a problem on citrus with a disease called HLB, or Huanglongbing as it's called, because it was first detected in China. I was consulted to help a citrus grower in Brazil, actually the largest citrus grower in the world. He couldn't control this disease, applying 300 to 500 gallons an acre. The labels was based on the label in the US, specified 15 gallons an acre by air and 300 to 500 by ground. As I've experienced since all my career with low volumes, I went to help him. After doing multiple tests, we were able to demonstrate the best control with a half a gallon an acre. Insecticide plus, it was actually a powder insecticide mixed with water and mixed with oil and adjuvant. Fantastic control of the disease. Killing an insect, a psyllid, is smaller than an aphid. So half a gallon is better than 300 gallons or 500 gallons. This has since been reduced to 0.3 of a gallon. Why? We must ask ourselves, why does it work? It gets to the target. And if it doesn't get to the target, there we have environmental pollution on a major scale. Asparagus, Mexico. This is in a desert area, Sonora, Caborca. The aerial applicator, who's also a farmer, was applying 10 gallons an acre. And also 2 gallons, and I was able to reduce it to 2 gallons an acre with fertilizer. Instead of applying the fertilizer diluted with water, took all the water out and only used enough water to clean out the hose from the pump to the aircraft. And for insect control, these chicharras, or cicadas, as you may call them in English, we reduced the spray volume to 1 quart. We sprayed the first field at 43 degrees Celsius, which is around 105, and the humidity was 17%. We had absolute 100% control in less than 1 hour. It's in the desert area, low volumes. Again, please ask yourself, where did the chemical go when you use high volume? It certainly didn't hit the target. I would like to thank you for your attention, and just to summarize, lower volumes provide better control, consistent results, for the very simple reason we put more on the target. At the moment, there's a major outbreak of locusts in Africa, Pakistan, and how is the locust being controlled? These are swarms of locusts. You people being pilots, if you ever get called to spray locusts, first thing you have to learn is you have to fly high, because if a swarm of locusts goes in the air intake on your engine, you'll be on the ground quicker than you'd anticipated, because it'll choke your engine. So the aircraft has to fly high, 100 feet, 150 feet to be above the swarm. And we use the chemical as pure as possible, with almost no water. The goal is, please, that I want you to take home with you from today is, think about keeping the spray droplet wet. Use mirrors. The droplet has to stay wet a minimum of 5 minutes. That's the confirmation that you did not lose it to evaporation, which is the first step. And the second thing is, when the droplets are wet, the chemicals are going to work better because the plant can absorb them. Plants do not absorb rocks. Very many thanks for your attention.
Well, thank you, Alan. I'm sure a lot of the folks watching the presentation were as astounded as I am. First of all, I'm sad to say that you just informed me that I've spent hundreds of my hours of my life wasting my time on pattern testing with water. but you know, everybody has to learn something. We do have a couple of questions for you. One question was asked, and this is, I guess the question is this an old wives' tale or a misconception or not? If you add something like Dawn dish soap in a mix, will that help if you don't use an adjuvant? I didn't ask the question. I'm just repeating it.
Dish soap will reduce the surface tension of the liquid. That's why it helps to wash the dishes. And what happens when you do this, and we've tested all these options in Brazil, dish soap, also soap to wash engines, it reduces the surface tension, which means that the equipment on the aircraft will produce a smaller droplet, but unfortunately, the dish soap will not protect against evaporation. So we will increase evaporation loss. We will increase drift. So in essence, I do not recommend using all the dish soap.
Okay, all right, that's
The
good.
oil, the adjuvant must have two functions. It must have an oil type function to conserve droplet size, and yes, something to reduce surface tension. But not too much of the soap, please, because this will increase drift.
Okay. And I guess the next question would be, all your research is fascinating, and maybe this is a political question, but with all of the research you've done, are you feeling like the manufacturers are looking at recommending lower rates? And if not, why not?
Okay, many of the manufacturers, yes, for South America, are looking at changing things and have changed the labels. As I said, practically all the product applied by air in South America is applied in what you would call very low volumes, 1 gallon or less. For the very simple reason, the operators have proven that we can control evaporation, and by controlling evaporation loss, we get better results. We get more product to the target. Jolene, this will be very interesting to you. I see you're listening there. You have a smile on your face. The labels have been developed based on small plot trials. I conduct the trials for my clients. Minimum field test for me is 100 acres. And what I look at is results and results. If it does not give the result, there's no point in wasting any more money. So that's what has happened. My job is, as I say, I'm an independent consultant. Just this morning, I had a request from Russia. I work all around the world. When all else fails, when they cannot control a pest, my name surfaces. So that's why I get called to all these difficult situations. And I love it because they expect me to pull a white rabbit out of my pocket, do a miracle, and very often I can. I didn't set out initially to work with low volumes. I've always been questioning how to apply chemicals all my life, working with major chemical companies. But now I've been almost 20 years working for myself as an independent consultant. And what I've found is every single chemical that's out there works better when we use less water. Every one of them.
Okay, another question for you. And Jolene or Brian, I guess you guys could jump in. Is this a requirement? Is this a should or a may? So if a label states a minimum of 2 gallons per acre or whatever a minimum is, can you apply at a lower rate, or would you be off label?
That is the delicate situation for Jolene. I respect the work you're doing. I don't want to cause a fight, but I think it's time for the growers, the farmers, the applicators to get together, because the data, all the data using water, for me, is irrelevant. We must address the issue of what works best. It's time to change the labels. I did a lot of work with 2 of the major chemical companies with fungicides, and we proved very dramatically using all types of equipment. In fact, that was a requirement of the test. I used all types of aircraft that were out there, all types of equipment, atomizers, nozzles, electrostatics, everything. And in every case, we had better disease control when we used less water, all the way from Louisiana to North Dakota.
Okay, and a lot